Hey there! Today we're diving deep into the vast, infinite cosmos to unravel some of the most chilling and mind-boggling facts about outer space. It's a realm that has intrigued humanity for centuries, but as we learn more, we realize it's filled with phenomena that are as terrifying as they are fascinating. So buckle up, because we're about to embark on a journey to uncover the top 10 scary facts about outer space. When we think about space, we often imagine it as a serene, silent expanse. However, lurking within this tranquility is an invisible threat: deadly radiation. Space is saturated with cosmic rays and solar radiation that can wreak havoc on the human body. Cosmic rays are high-energy particles originating from outside our solar system, while solar radiation is emitted by our sun. These particles are so energetic that they can penetrate the walls of spacecraft and even the skin and bones of astronauts. On Earth, we are protected from these harmful radiations by our planet's magnetic field and atmosphere. But in space, astronauts are exposed to levels of radiation up to 100 times higher than what we experience on the ground. Prolonged exposure to these high levels of radiation can lead to serious health issues, including an increased risk of cancer, cataracts, and neurological disorders. The damage doesn't stop there. Radiation can also interfere with electronic equipment and spacecraft, posing a significant challenge for long-duration space missions. Scientists and engineers are actively researching ways to mitigate the effects of space radiation to ensure the safety of astronauts on future missions. From developing advanced materials for spacecraft walls to creating protective suits for astronauts, the goal is to reduce exposure and shield the human body from these invisible yet deadly particles. Understanding and overcoming the challenge of space radiation is a crucial step in our journey to explore the final frontier. The vacuum of space is not only devoid of air and pressure, but also sound. Sound waves require a medium like air, water, or solid objects to travel through. In the vacuum of space, there is no such medium, resulting in complete silence. This silence of space is a profound experience, starkly different from the constant barrage of sounds we are accustomed to on Earth. Imagine being surrounded by stars, planets, and galaxies, yet enveloped in an absolute silence. This is the reality of space. Astronauts who have conducted spacewalks describe the experience as surreal. They can hear the sound of their own breathing and the hum of their spacecraft, but beyond their suit and the confines of their spacecraft, there is silence. This silent vacuum also plays a critical role in the formation and evolution of celestial bodies. In the absence of air resistance, objects in space can travel at incredibly high speeds without slowing down. This principle is what allows spacecraft to travel vast distances across our solar system and beyond. It also means that space debris, tiny fragments of broken satellites and rockets, can become lethal projectiles traveling at speeds of up to 28,000 kilometers per hour. The Great Void, also known as the Boots Void, is one of the most vast and empty places in our known universe. Discovered in 1981 by astronomer Robert Kirshner and his team, this gigantic space is around 330 million light-years in diameter. To give you an idea of its enormity, our entire Milky Way galaxy is just about 100,000 light-years across. Now imagine a sphere that could fit around 2,000 of our galaxies side by side. That's the Great Void. This colossal emptiness is located in the constellation Boots, hence its name. Inside this void, there are very few galaxies, around 60, which is shockingly low compared to what we would expect in such a huge volume of space. Normally, in a space this size, we'd expect to find around 10,000 galaxies. The scarcity of cosmic structures in the Great Void makes it a subject of intrigue and mystery. What caused this gargantuan empty space? Some scientists propose that it might be a result of cosmic inflation, a theory that suggests the universe expanded rapidly just after the Big Bang. The vacuum of space is one of the most hostile environments imaginable. Space is not a complete vacuum, but it's pretty close, with only a few hydrogen atoms per cubic meter. On Earth, we live at the bottom of a protective ocean of air, but in space there's virtually no air, which means there's no air pressure. For astronauts, venturing into this vacuum requires state-of-the-art protective gear. Without air pressure, the human body cannot survive. In the vacuum of space, the lack of pressure would cause the nitrogen dissolved in our bloodstream to form bubbles, leading to decompression sickness or the bends. This is the same condition that can affect divers if they ascend to the surface too quickly. Additionally, the lack of atmosphere means that there is no medium for sound waves to travel through, resulting in complete silence. An astronaut could be screaming at the top of their lungs just outside their spacecraft, and it would be completely silent. The vacuum of space also poses a challenge when it comes to temperatures. With no atmosphere to moderate temperatures, space can be extremely hot when the sun is shining directly on an object and frigidly cold in the shade. This stark contrast creates an environment where only the most well-equipped and resilient can survive. The vacuum of space is a constant reminder of the delicate balance of conditions that support life on Earth and the harsh reality of the cosmos beyond our planet. The dark expanse of space is awe-inspiring and breathtaking, but it also holds terrors that are as unfathomable as the universe itself. While the twinkling stars and the serene glide of planets may paint a picture of peacefulness, space is far from a tranquil haven. It is a realm of extremities where temperatures can swing violently and radiation permeates every corner. In this endless darkness, there are black holes, regions in space where gravity is so strong that nothing, not even light, can escape from it. These cosmic behemoths can tear apart stars and swallow entire galaxies. The event horizon, which is the boundary around a black hole, represents the point of no return. Anything that crosses this boundary is irretrievably drawn into the black hole, disappearing from our observable universe. Space is also home to neutron stars, the remnants of massive stars that have exploded in supernova. These stars are incredibly dense, packing a sun's worth of mass into a sphere just a few kilometers in diameter. The gravitational field near a neutron star is so intense that if an object were to fall from just 1 meter away, it would hit the star's surface at around 2,000 kilometers per second. As we turn our eyes to the sky and dream of exploring the cosmos, there is a hidden danger that orbits above us: speeding space debris. Space debris, or orbital debris, refers to defunct human-made objects in space. Old satellites, spent rocket stages, and fragments from disintegration, erosion, and collisions. There are millions of pieces of space debris, and they are traveling at speeds of up to 28,000 kilometers per hour, fast enough to cause catastrophic damage to satellites, spacecraft, and even the International Space Station. The risks posed by space debris are not hypothetical, they are real and present. In 2009, a defunct Russian satellite collided with a functioning Iridium communications satellite, creating thousands of pieces of debris. This event highlighted the growing problem of space debris and the need for sustainable space practices. Cleaning up space debris is a monumental challenge. Unlike pollution on Earth, we can't simply send a cleanup crew to space. The vastness of space, combined with the high speeds at which debris travels, makes capturing or diverting these objects incredibly complex and dangerous. Organizations around the world, including NASA and the European Space Agency, are actively researching and developing technologies to tackle this issue, from nets and harpoons to lasers and robotic arms. Embarking into space means entering a realm where the concept of day and night as we know it on Earth is completely transformed. The prolonged darkness of space is an ever-present aspect of this mysterious expanse, creating a unique and challenging environment for both humans and machinery. In the void of space, sunlight is unfiltered by an atmosphere, resulting in harsh lighting conditions when the sun is visible. Conversely, when the sun is out of view, an impenetrable darkness prevails. Astronauts aboard the International Space Station experience this rapid transition between extreme light and darkness every 90 minutes as the station orbits the Earth. This constant shift can have profound effects on the human body, disrupting sleep patterns and circadian rhythms. The prolonged darkness of space also conceals countless celestial bodies and phenomena. Objects that are not illuminated by a star's light or are too distant for their light to reach us remain shrouded in mystery. This is where technologies like infrared telescopes come into play, allowing us to peer into these dark regions and unveil the secrets they hold. The vastness of space holds a beauty that is unparalleled, but it also embodies a profound sense of isolation. Cosmic loneliness encapsulates the feeling of being amidst the immensity of the universe, surrounded by an infinite expanse of stars and galaxies, yet being profoundly alone. This solitude is not just a philosophical musing, it has real implications for space travel and exploration. Astronauts on long-duration space missions experience this isolation firsthand. Cut off from the familiar sights, sounds, and social interactions of Earth, the loneliness can be overwhelming. Space agencies like NASA have recognized the importance of addressing this psychological challenge, investing in research and support systems to help astronauts cope with the isolation. The question of cosmic loneliness also extends to our search for extraterrestrial life. As we scan the skies with our telescopes and send probes to distant planets and moons, we are also searching for companionship in the cosmos, for signs that we are not alone in the universe. The vast distances between stars and galaxies mean that even if there is other life out there, they may be unreachable, further accentuating the feeling of loneliness. Venturing into space means venturing into the unknown. Space, with its unfathomable distances and extreme conditions, is a realm filled with mysteries and uncertainties. The unpredictable nature of space is evident in various phenomena and challenges that scientists and astronauts must grapple with. One of the most unpredictable aspects of space is its weather. Solar flares, for instance, are sudden eruptions of energy from the surface of the sun, releasing bursts of radiation and charged particles into space. These solar flares can have dramatic effects, disrupting satellite communications and posing serious risks to astronauts in space. Similarly, cosmic rays, high-energy particles from beyond our solar system, can damage spacecraft and pose a significant health risk to astronauts. Another unpredictable aspect of space is the presence of micrometeoroids and space debris. Traveling at incredibly high speeds, these small particles can cause significant damage to spacecraft. The famous Apollo 12 mission, for instance, was struck by lightning just 36 seconds after liftoff, causing a power surge and triggering multiple warning lights and alarms. It was later determined that the lightning had temporarily knocked out the spacecraft's fuel cells, a stark reminder of the unpredictable nature of space and the challenges it poses. In the grand tapestry of the cosmos, dark energy remains one of the most intriguing and perplexing mysteries. It represents a fundamental unknown in our understanding of the universe, acting as a counterforce to gravity and driving the accelerated expansion of the universe. Despite its pervasive influence, dark energy remains elusive, an enigma that challenges our perceptions and theories about the cosmos. The concept of dark energy emerged from observations of distant supernovae, which revealed that the universe is not just expanding, but doing so at an accelerating rate. This discovery was groundbreaking, as it contradicted the prevailing belief that the universe's expansion should be slowing down due to gravity. To account for this unexpected acceleration, scientists proposed the existence of dark energy, a mysterious force that permeates all of space and exerts a repulsive effect, counteracting gravity. The nature of dark energy is a riddle that has baffled scientists since its discovery. It does not emit, absorb, or reflect light, making it invisible and undetectable through traditional means. It is believed to make up about 68% of the universe, yet its properties remain largely unknown. Some theories suggest that dark energy is a property of space itself, while others propose the existence of a new type of energy field or even modifications to our understanding of gravity. Venus, often dubbed Earth's sister planet because of its similar size and proximity to us, has always been somewhat overshadowed by our red neighbor Mars in the quest for extraterrestrial life. However, a recent discovery has cast a surprisingly bright spotlight onto this scorching, cloud-covered world. For the longest time, Venus was dismissed as a possible haven for life. With surface temperatures hot enough to melt lead and an atmosphere thick with carbon dioxide and clouds of sulfuric acid, it seemed an unlikely place to find any signs of life. But the universe, as it often does, threw a curveball at us. In 2020, scientists made an announcement that caused quite a stir in the astronomical community. They had detected traces of a gas called phosphine in the clouds of Venus. Now, why was this discovery so groundbreaking? Phosphine is a molecule made up of phosphorus and hydrogen. On Earth, this gas is primarily associated with life, produced by bacteria living in oxygen-free environments. The clouds of Venus, where the phosphine was detected, have temperatures and pressures that are somewhat Earth-like compared to the planet's inhospitable surface. This led to the tantalizing possibility: could there be life floating in the Venusian atmosphere? Before jumping to conclusions, researchers meticulously looked for other explanations. Volcanic activity, lightning, and even meteor impacts were considered as potential sources of the phosphine. Yet, none of these scenarios could produce the amount of phosphine that was observed. The instruments and methods used to detect the phosphine underwent rigorous scrutiny, with teams double-checking data and ensuring the signal was genuine. The presence of phosphine doesn't confirm life on Venus, but it does open the door to this exciting possibility. To find more answers, missions to Venus are now being considered with renewed interest. By sending probes to study its atmosphere directly or even to float in the clouds, scientists hope to determine the origin of the phosphine and see if the thick, acidic clouds of our neighboring planet might indeed harbor some form of life. In the grand tapestry of space exploration, the phosphine discovery on Venus reminds us of an essential lesson. Sometimes the search for alien life may lead us in directions we never anticipated. Mars, our captivating neighbor, has always been at the center of mankind's fascination when pondering the existence of extraterrestrial life. With its haunting red landscapes and vast valleys, it's a planet that has inspired countless tales of Martians and space invasions. But recently, some real, tangible clues have emerged from this distant world that could hint at the existence of ancient life. The term organic might conjure up images of green foods or farming practices, but in the realm of chemistry, it simply refers to carbon-based molecules, which are life's building blocks. Such molecules are crucial because all known life forms on Earth are carbon-based. In 2018, the scientific community was abuzz with excitement when the Curiosity rover, NASA's mobile laboratory rolling across Mars, discovered organic molecules preserved in Martian rocks. These rocks, located in an area named Gale Crater, are estimated to be about 3.5 billion years old. This discovery means that at around the same time life was gaining a foothold on Earth, Mars had the ingredients necessary for life. What makes Gale Crater especially interesting is that it's believed to have once contained a lake. With the discovery of these organic molecules, one can't help but imagine a past Mars where water-filled lakes or oceans nurtured early forms of life. However, it's important to note that the presence of organic molecules doesn't directly point to life. Mars is a dynamic planet with a history of volcanic activity. These organic molecules could have been formed by non-biological processes or even delivered from outer space via meteorites. Despite the uncertainty, this discovery adds another layer to Mars's already complex and intriguing story. Scientists, with the help of rovers like Curiosity and future missions, continue to unravel the mysteries of the red planet. Each discovery, each hint of ancient water or molecule, draws us closer to answering that age-old question. Are we alone in the universe? For now, the presence of organic molecules on Mars stands as a testament to the planet's potential to have supported life. As we dive deeper into its secrets, who knows what other revelations await us? Far from the warmth of the sun in the chilling depths of our solar system lie two icy moons that, contrary to their frigid exteriors, might harbor the warmth of life deep within. Enceladus, a glistening moon of Saturn, and Europa, one of Jupiter's largest moons, are more than just frozen celestial bodies. They are worlds of intrigue and promise. At first glance, Enceladus might appear as just another ice-covered sphere, but it hides a dynamic secret beneath its surface. In 2005, the Cassini spacecraft, while exploring Saturn and its moons, witnessed stunning plumes of water vapor and ice particles erupting from the south pole of Enceladus. These geyser-like jets bursting forth into space indicated that beneath its icy shell, Enceladus might be hiding a vast subsurface ocean. Europa, with its cracked, ice-covered surface, tells a similar tale. Observations from various missions and telescopes have provided strong evidence that a massive subsurface ocean, potentially twice the volume of Earth's oceans, exists beneath Europa's icy crust. These observations, coupled with the Moon's induced magnetic field, suggest the presence of a salty, liquid water ocean. But why is the discovery of these oceans significant? Water, as we understand it, is a fundamental ingredient for life. On Earth, where there's water, there's often life. These hidden oceans on Enceladus and Europa offer the tantalizing possibility that, in their warm depths, microbial life, or even more complex organisms could exist. It's incredible to imagine that in such extreme and distant environments, life might find a way. The potential existence of hydrothermal vents on the ocean floors of these moons further amplifies this possibility. On Earth, hydrothermal vents in our ocean's abyssal depths teem with life. These ecosystems thrive without sunlight, relying instead on the chemicals spewed out by the vents for energy. Could similar vents in the oceans of Enceladus or Europa be home to alien life forms? As technology advances, our gaze turns not just to the distant stars, but also to these icy worlds in our backyard. Future missions to these moons aim to study their oceans more closely, hunting for signs of life or the conditions that might support it. The discovery of these subsurface oceans has reshaped our understanding of where life might exist beyond Earth. It's a compelling reminder that sometimes the most exciting mysteries and potentials for discovery lie just beneath the surface. The TrappistOne system, discovered in 2017, was a breakthrough in our quest to understand the universe and the possibility of life beyond Earth. Situated just 40 light-years away from us, it's relatively close in astronomical terms. When you think of the vastness of space, 40 light-years might seem enormous. But in the grand scale of the universe, this system is practically our neighbor. What makes TrappistOne truly special is the sheer number of Earth-sized planets it contains. 7 to be exact. These planets are not just any regular planets. They are remarkably similar in size to our own home Earth. This resemblance in size leads scientists to believe that these planets could potentially have similar conditions to Earth, which opens up the possibilities of them hosting life. The most intriguing aspect of these 7 siblings is that 3 of them are comfortably nestled in what's known as the star's habitable zone. This is a region around a star where the conditions might just be right to support liquid water on the planet's surface. As we know, water is essential for life, at least life as we understand it. If there's liquid water, there might be an environment conducive to life. Furthermore, the star at the center of the TrappistOne system is a red dwarf. These types of stars are cooler and less luminous than our Sun. Because of this, the habitable zone where temperatures could allow for liquid water is closer to the star. This means that the planets in this zone, with their potential watery reservoirs, are in close proximity to their parent star, making them tantalizing targets for future observations. There's a significant effort in the scientific community to study these planets in detail. Using advanced telescopes and observational techniques, researchers hope to decipher the atmospheres of these planets. If they can determine the composition of these atmospheres, they could look for signs of life, or at least conditions favorable for life. The TrappistOne system, with its Earth-like planets and potential for water, remains a beacon of hope in the search for extraterrestrial life. Deep in the cosmos, in the vast expanse of our universe, there lies a phenomenon that has both baffled and excited astronomers for years: fast radio bursts, commonly abbreviated as FRBs. First discovered in 2007, these are intense, millisecond-long spikes of radio energy that seem to come from very, very far away, and their origins remain one of the most captivating puzzles in modern astronomy. Imagine for a moment a lighthouse. It sends out a quick, powerful beam of light that sweeps across the landscape and then disappears, only to repeat again after a while. FRBs are somewhat similar in nature. They are these extremely short-lived yet incredibly powerful bursts of radio waves that, when first detected, left many experts scratching their heads. The distance from which these FRBs are coming from is astounding. Through various observations and calculations, scientists have determined that many of these signals are originating from galaxies millions to billions of light-years away. To put that into perspective, even the light from our closest neighboring galaxy, Andromeda, takes about 2.5 million years to reach us. That these brief signals from far-off galaxies manage to reach us is a testament to their immense energy and power. But what causes FRBs? That's where the plot thickens. There have been numerous theories. Some suggest that these could be the byproducts of massive cosmic events, like the collision of neutron stars or the eruption of supermassive black holes. Others even proposed more exotic theories, like signals sent by advanced alien civilizations trying to reach out to the cosmos. While the extraterrestrial hypothesis is undeniably thrilling, researchers tend to look for more conventional, natural explanations first. In recent times, some breakthroughs have been made. For instance, certain FRBs have been observed to repeat coming from the same location in the sky. This repeater behavior might provide clues about their origins. Are they from neutron stars in the throes of death? Or are they the result of some other high-energy astrophysical process? The hunt to uncover the mysteries of FRBs is ongoing, with newer telescopes and technologies paving the way for deeper insights. These enigmatic signals from the cosmos might not only teach us about the vast, intricate workings of the universe, but could also offer hints, no matter how subtle, about the possibility of life beyond our tiny blue planet.